Okay, in this video we're going to look at the second question from this step 1 paper from June 2016. I'm going to work through as many as I can from this paper in a series of videos throughout the year. So question 2, definitely different from the question 1 if you've worked through that one. Question 1 didn't really require too much in terms of knowledge of the syllabus, whereas in question 2 we're suddenly very much into something that requires you to know quite a lot of the content of A-level single maths. Again, I'm going to assume that you've probably got a copy of this paper, so it may not be visible throughout the whole video very easily, but let's have a look at the question here. It says differentiate with respect to x this whole function with a, b, c, d, and e constant. Simplify your answer as far as possible, we'll come to that later, and then hence do 3 integrals. Okay, so if a question asks you to differentiate something and then says hence integrate something, there's a big clue there. It feels like these things that we're going to have to integrate are in some way going to be related to the answer from the earlier part of the question, and that's always going to be true, well, most of the time true in step questions, that the second parts are going to follow on in some way from the first. So I expect before doing this question that what we have to do is to do something like differentiate all of this and then see each of these as different cases of the derivative of this with constants that we'll have to choose. But we can't really get too far with thinking about this part of the question until we've just done this differentiation. So we better get on with that. So I've just written it out again here. So it's just restating the question. It says differentiate this. Now, in order to compute this derivative, we can just step back for a second and look at the structure, and it hopefully won't be as bad as it looks. I've got plus here, so we can see 2 different parts of the function to differentiate, and both of these 2 parts are products. Okay, so it's a function times another function, a function times another function. The right hand side looks slightly simpler to me than the left hand side. Okay, so actually let's start with the right hand side, and I'm going to tackle this one piece at a time rather than trying to write out the whole derivative all at once. I'm going to do it in a few steps. So on the right hand side, the awkward thing to start with is this derivative of root 1 plus x squared. So let's just have a look at that first. So if we differentiate the square root of 1 plus x squared, well, you don't have to write out every step here, by the way. I'm going to do it as thoroughly as I can for this video. So I want to differentiate 1 plus x squared to the power of a half. You should put in a good amount of working there. I mean, don't skip too many of these steps. So by the chain rule, what I get is 1/2 1 plus x squared to the minus 1/2, and then we multiply by 2x, the derivative of 1 plus x squared by the chain rule. So a half times 2x is x, so I've got x times 1 plus x squared to the minus a half, or if you want to, you could write that as x divided by the square root of 1 plus x squared. Okay, so we've definitely made a start at this problem. Okay, so once we've got that, now actually if I were to try and differentiate the whole of this, then, well, we know the product rule, which says differentiate one part, leave the other alone, plus the alternate of that. So again, I'm assuming that you know the content of A-level here. Step problems take us beyond the ordinary questions. So if you need to look up calculus, product rule, chain rule, all that stuff, go back to some other videos on that before you attempt this problem. Now, so applying the product rule, then, if I do the derivative of dx plus e times the square root of 1 plus x squared, well, having just written this down, that makes this a lot easier. Okay, so I differentiate dx plus e and just get d, and multiply it by the other part of the function here, root 1 plus x squared, and then we add that to the dx plus e, now multiplied by x over the square root of 1 plus x squared. Okay, and although the question does talk about simplifying our answer fully, I'm not going to do anything else with this yet. There might be some sensible things to do with it, but I'm going to wait until I've got the other part of the derivative to do the simplification. Okay, just to so we can see what we've got before we do simplify. But we've got that half. Let's do this same thing to the other half. Now, so if we were to look at this part of the function, I think is the hardest, then log of x plus root 1 plus x squared. So we've got to apply the chain rule here again. Now log of something differentiates to 1 divided by that thing, so we get 1 over x plus the square root of 1 plus x squared. and then by the chain rule, we have to multiply by the derivative of the inside function. And again, you see the order I've done this question in, if you step back and think about the strategy here, it's quite useful, because again, I need the derivative that we've already worked out here, again, as part of the answer. So, so now I multiply by this, which is 1 plus, and then the derivative of root 1 plus x squared, which is this, so x divided by square root 1 plus x squared. And again, clearly various ways that I might be able to think about simplifying this, but just for the minute I'm going to leave it as it is, I think. Actually, I don't think that's sensible. I think I'm going to try and simplify this just a little bit, because when you might see that this bracket here is going to combine quite neatly. So let's just do the obvious things in terms of simplifying this. So here I've got something. This is kind of awkward. I'm going to put this over a common denominator, and so we'll put this all over a common denominator of the square root of 1 plus x squared, and you'll see what happens then. Okay, I've got root 1 plus x squared plus x. Okay, the 1 is root 1 plus x squared over root 1 plus x squared, and then plus this. And you see what's happened is that I've got root 1 plus x squared plus x on the top here and on the bottom here, so they're actually going to cancel out and give us a much simplified answer, 1 divided by the square root of 1 plus x squared. So definite value in simplifying at that stage. Of course, we could do it later. I mean, it's not, we're trying to find the most efficient route through the problem, but in reality, we don't always find the best route. We just find a route that works, and just simplify where we can. Okay, so that's that. Now that's going to make the next part much easier then, because if I try to differentiate this whole left-hand part of the function, then ax squared plus bx plus c times the logarithm of x plus the square root of 1 plus x squared, then so I've got, by the chain rule, ax squared plus bx plus c times the derivative of this, which is this function we've just worked out. So I've got ax squared plus bx plus c divided by the square root of 1 plus x squared, and then differentiating ax squared plus bx plus c gives us 2a plus b, and then that's all multiplied by the right hand part of the function, log of x plus root 1 plus x squared. Okay, so actually I think we're done, right? And well, I mean, we haven't yet simplified our answer as far as possible, but now the answer to the whole problem to differentiate this is just to take our answer here for the right hand side and add it to the answer to the left hand side. Okay, so let's do that, and then we'll just try and simplify whatever we can. So I'm not going to write out the whole thing. I'm just going to put a little mark in like that, d by dx of the whole thing equals, and let's write it down in the order in the question. So this one first, so ax squared plus bx plus c divided by the square root of 1 plus x squared plus 2a plus b times the logarithm of x plus root 1 plus x squared, and then we'll add that to this stuff here, d times the square root of 1 plus x squared plus dx plus e times x over the square root of 1 plus x squared. Okay, so we just want to make sure it's simplified as far as possible. Now, of course, we've done some of the simplification along the way, and you might have done this question and not cancelled this stuff out yet, and so you've got to decide at some point when you're going to stop and say, well, this is as simple as it gets. I think what I can see here, though, is I've got these two terms. They're both over root 1 plus x squared, so I definitely want to combine those, and I think this term here as well, the d 1 plus x squared. Actually, I'm going to do this without writing it all out again. If you kind of turn this into a fraction and multiply it top and bottom by root 1 plus x squared, so let's multiply the bottom by root 1 plus x squared and multiply the top by root 1 plus x squared, well, that will just get rid of this square root here. So I'd have d times 1 plus x squared. So I've actually effectively got these three terms all over 1 plus x squared, and everything on the top are polynomial terms. Okay, so let's see what we've got on the top. We've got an ax squared, and I've also got a d times x squared here, And actually this one, dx plus e, that would be dx times x, that would be dx squared as well. So we've got a plus 2 times d x squared. The linear term, I've got bx, and no linear term here, but I've got an ex here. Okay, so that's going to give us b plus e times x, and for the constant term on the top I've got a c here and a d here, so we're going to have plus c plus d, all divided by the square root of 1 plus x squared, and then I've still got this term here, which I'm not going to do anything with, 2a plus b times the logarithm of x plus the square root of 1 plus x squared. And I think I'm happy that that's about as simple as we're going to get for this derivative. It's not, it's still got to have these 5 constants in there somewhere, so we're not going to expect a really neat and compact answer. But I've got it as a quadratic over this function plus something to do with this logarithm, and I think that's pretty good. So we'll go on to the second part of the question. And the second part of the question says, hence integrate these functions, log x plus root 1 plus x squared, 1 plus x squared, and x log root x plus root 1 plus x squared. So now my strategy here then is going to try to use the first part of the question and say, okay, well, are there constants a, b, c, d, and e that we can choose so that each of these functions, so this whole expression here reduces to each of these functions. If it is, you see, if I can say, well, okay, if I just take a to be this, b to be this, c to be this, and I get this, well, that means that I can integrate this function by going back to the original thing we differentiated and using those constants. Okay, so think about that idea for a second if you need to, and then we'll go on to answer this question. Okay, and I've just realized I made a slight mistake here, didn't I? When you differentiate ax squared plus bx plus c, you actually get, 2ax plus b. So actually in here there's a 2ax, and here there's 2ax plus b. Sorry about that. That will be important as we go on to the rest of the question. And so all I've done here is just rewritten that out, so I've got it at the top of the page, and I can now go on to solve these questions. So I've got when we differentiated this whole expression to start off with, this is what we ended up with. Okay, so first, part 1 then, we want to integrate log x plus root 1 plus x squared dx. Now, so I'm going to try and choose a, b, c, d, and e to make this equal to this. Now, we can see we've got this log x plus root 1 plus x squared, so I need to make this so it's just 1, right? So if this is just 1, so 2ax has to disappear, so that means I would have to take a equals 0, and I can take b equal to 1, right? And that would make this term just 1 times this, and that would be great. Only problem is, I've also got this term here, so I need to make this whole thing 0, right? If that goes away, then this all just reduces to this. So let's try and make all of this 0. Well, if this quadratic term has to be 0, so I'd have a plus 2d is equal to 0, but a we've taken to be 0 already, so we also need to take d to be 0. This term needs to be 0, so b plus e times x is 0, but b is 1, so e has to be minus 1, then we would get a 0x. I'm just hoping these all work out. And then this final one, c plus d, is going to have to be 0. Well, d is already 0, so we need to take c 0 as well. Okay, so with those choices of a, b, c, d, and e, then this is exactly the integral that we want. So when I integrate this, I would get whatever this is with these choices of a, b, c, d, and e. Okay, so a is 0, b is 1, c is 0, so I get just 1x here. So I've got x times log x plus root 1 plus x squared. And then dx plus e, so d is 0 and e is minus 1, so I've got minus the square root of 1 plus x squared. And now I should add a constant of integration. Usually we'd use c, but c is a part of this question, so I think I'll just use some other constant. Let's just use k, doesn't really matter. the main, I mean, you should have the constant of integration, but in a step problem, it's there's so much else you've done. It's not like it's not necessarily like 1 mark in the A-level exams, but there we go. We've done part 1. So we just have to try and do the same again for parts 2 and 3, and I imagine they'll make it slightly harder for us to find the constants, but let's see how it goes. Next one is the square root of 1 plus x squared with respect to x. Not an easy integral to do otherwise. And so we look at this, and so there's no log term to start off with here. So we look at that, and I'm going to probably have to take then a equals 0 and b equals 0. That's going to be the only way to eliminate this log term. So that's certainly a start. Now, how do you get this term to be root 1 plus x squared? I mean, it doesn't seem quite in the right form. So let's just think about, if I were to rewrite this root 1 plus x squared with something divided by root 1 plus x squared, what would I get? It's the same thing as the square root of 1 plus x squared on the bottom, and then I times the top by root 1 plus x squared, so I get 1 plus x squared. Okay, this will be true. So I just need to choose the quadratic on the top then, so that I've got x squared plus 1. So if I look at the x squared term, that's a plus 2d. I need a plus 2 times d. I need a plus 2 times d to be equal to 1 for the 1x squared, but a is 0, so I've got 2d equals 1. So that means that d is going to have to be equal to 1/2, and I need to make the constant term 1 as well, so that's c plus d. So c plus d equals 1, but d is 1/2, so we also have to have c equal to 1/2, and then we just have to look at the linear term b plus e times x. There's no linear term here, so that's 0. b plus e is 0, but b is 0. So that gives us e equal to 0, and so again we're done. I just need to substitute these numbers back into the original function and see what we've got. So a is 0, b is 0, c is 1/2, so I get 1/2 log x plus root 1 plus x squared, and then dx plus e is 1/2 x plus 0. So just 1/2 x times the square root of 1 plus x squared, and then again some constant of integration. And that's part 2 done. Right, so part 3 hopefully going to come out by a similar sort of approach. And in part 3 we want to integrate x times the logarithm of x plus the square root of 1 plus x squared with respect to x. And okay, so we just play the same game. This time we've got this stuff is not present, and this stuff is just equal to x. So we just need to take, for this to be equal to x, I need 2ax to be equal to just 1x. So that means that a is going to be equal to 1/2, and b is going to be equal to 0. Again, that gives us this part. Again, I just now need to eliminate this part of the problem. So a plus 2d times, so this time a plus 2d has to give us 0. Well, a was 1/2, so I've got 2d equals minus 1/2, so d equals minus 1/4. B plus e has to be 0, but b is 0, so that just gives us e equals 0, and c plus d equals 0. So d is minus 1/4, that means c must be plus 1/4, and then we can just plug them back in again. Right? So once you've got the strategy, once you've worked out how to do the problem, filling in the algebra is not so bad. But it's still complicated. I mean, it's not. You've got to see through this complexity, and just sort of stay calm, and and continue even when the algebra is more complex than what you'd be used to in an A-level exam. We just sort of just plug away at it. Don't worry if there's fractions and that sort of stuff. So let's put the final numbers in. I end up with ax squared plus bx plus c. So here that's 1/2 x squared plus 0x plus 1/4. So half x squared plus 1/4 times log x plus the square root of 1 plus x squared. And then dx plus e is just minus 1/4 times x plus 0 times the square root of 1 plus x squared. And then again, we'll have a constant of integration. And I think we are done. It would be possible to pull a fraction out of this whole expression or something and write it as a a quarter times something else if you wanted to, but that we have we've got the final answer here, and we're not going to be penalized for exactly the form as long as we it's in a simple form. There's no obvious simplifications that we can make here. So that's great. So I hope that was useful. I'll try and do some more of these step questions throughout the year. So let me know if you have any comments or suggestions, and good luck with the next question. All of these questions, of course, are publicly available. I'll try and remember to put a link below to the questions so you can download them. Make sure you have a go at them before you watch the videos, and then try to just watch the videos once you've already solved the problem, and compare your answers to how I go about them.